So let's continue the idea of classical test theory through factor analysis. So with factor analysis, we're looking for patterns of correlations among observed variables. So essentially our items and how are the items grouping together. And what we're looking for are these underlying latent factors. You can think of this as the subset of variables that are clustering together. So how are the correlations actually clustering together within our 15 items? It is a statistical repackaging technique where we're trying to find a small number of constructs that are underlaying this larger idea of tests or items or variables. This is completely math-based that are trying to verify our theoretical constructs. So when we created this measure, we think that there's 5 different factors, 5 different ideas, and this is 100% math-based that are trying to see, does the math, does the way those items group together match our theory? There are 2 types. With exploratory, we have absolutely no preconceived notions. We're just letting the data fit the way that we want, that it wants to. With confirmatory, we're now laying over those 5 factors that we thought it was and seeing, does the data match the model? We are not getting into confirmatory factor analysis. That's using SEM techniques. This is all exploratory. And it starts with this correlation and this correlation matrix. So if I have 5 items that I am correlating with the 5 items, so 5 items correlated to themselves, I'm going to highlight the ones that are large correlations. So all of these are above a 0.4, but they're really all very strong correlations. When I get rid of them, the non-strong correlations, what I'm noticing is that these 3 items, Head Start, Healthcare, and Welfare, those are the items that are grouping together, and these 2 items are grouping together, but they have no correlation with these other ones. So we're looking at 2 potential factors. When I look at what they are called, or what the items are about, I'm going to name them. So factor 1 I'm going to call how some people feel about social programs, and the other 2 items are about security and order. Sometimes it's not as clear as those. Those were strong correlations. When we're looking at the factor loadings, it's the same concept. So we're looking at how these are loading on this first group. So with these first items, we can see that they're loading, they're all above a 0.4, and they're definitely not loading on this factor. But especially when we get down here, a 0.39 is really close to loading, but it's not. A 0.62 is better, loading on factor 2. But this defense item, that is loading on both factors. That is called cross-loading. That's a problem. That means that the variance of this item is loading on 2 different constructs. It's going to be a problem. So factor analysis is extracting the underlying factors, and it's based on the largest packet of variance in the set of correlations. This gets into some really nasty correlation matrix math, but each matrix is going to be given an eigenvalue and a corresponding eigenvector, which we're calling factor loadings. So eigenvalues that are above a 0.1 are considered a pocket of variance, that we are going to retain. We're going to keep it, we'll see if it's real or not real later. But we're going to say that that's enough for us to think that it's a real factor. And then these factor loadings, we want to be above a 0.4. And the factors are representing independent packets of variables. They're not correlated and they do not overlap, or should not overlap. The first factor, the first eigenvalue, is going to explain the largest packet of variance. The second is the next largest, and so on. And we're doing this with principal component analysis. So this is the tool in SPSS that we're going to be using to pull out these different extracted variables, or extracted variance factors. When we get to the output, there's quite a bit more output that we are looking at. There is a KMO test, and we want that to be above a 0.8. And that's going to tell us that we have adequate sampling to do this analysis. The Bartlett's test, we want to be significant, which will verify that this data is appropriate for this analysis. there's going to be a table of communalities. This is how the item compares to the whole. So we looked at this in the last video, in the last video. It's a 0.4 or above, and it's how it correlates to the whole, so the item to the whole. There's going to be a table that talks about total variance explained. This is our eigenvalues and our cumulative percent explained. So that, how much of the variance does that factor explain? There's going to be a scree plot. This might be a new plot for you to look at. It's going to show you how many factors to retain above a 0.1, and it's going to give you the relative size of the factors. You'll have a component matrix, which we're going to skip, and we're going to use the rotated one instead. Within this rotated matrix, you're going to highlight all of the factor loadings that are above a 0.4. That's going to show you which items are loading onto which of the factors that it retained, and then you can name each factor based on the item content, just like I showed you a few slides ago. Any item that is cross-loading, those are problem items and should probably be deleted. When we get to SPSS, we're going to click through several things. So it starts with analyze, dimension reduction, and then factor. We're going to go to descriptives and click the KMO and Bartlett's test of sphericity. We're going to do the method of principal component. So we could do a different method, but we're going to use principal components. That's the default. We're going to click scree plot here. And then under the rotation, we're going to click Varimax. So let's look at that. So I'm going to go to analyze, dimension reduction, factor. I'm going to scroll all the way down and change to display variable name. I'm going to scroll all the way down to the ones that have been recoded, because as we found, that can be a problem. That if you have some that are worded positively and some that are worded negatively, it's going to be really confusing, and all of your matrices are not going to merge correctly, or they're going to look really bad. So I'm going to click there, extraction, scree plot, rotation, Varimax. Actually, I'm going to go back to extraction. Just a quick thing that I'm going to show you. The default is it's going to be based off of eigenvalues greater than 1. You can fix the number of factors. So if you have very strong reason that it's going to retain 4 factors, but there's only 3 that you want it to retain, you can force it right there. We're just going to leave that though. Hit OK, and here we go. So our KMO is above a 0.8, so we're good there. Our Bartlett's test is significant, so we're good there. We can look right here and see the item total correlation. We saw that in the item analysis as well. So everything is above a 0.4, so these are all loading really nicely to the whole. That does not show you how many different factors there are within the whole. That's going to be this one. So here I have 1, 2, 3, 4 different factors that have an eigenvalue above a 1. The first factor is explaining 32% of the variance, and all 4 factors together are explaining 56% of the variance. When we look at the scree plot, we can definitely see that we have one major factor, and then when we hit the elbow, they just kind of fade from there. So one major factor. The elbow is still retaining 1, 2, 3 above this 1, but they're pretty small. I'm not really convinced that they could even be just based on chance. But we're retaining 4 for now. We're going to skip this one and look at the rotated components matrix. And what I would do is I would highlight everything above a 0.4 for all 4 of these. That's going to then show me which items are loading onto these 4 factors. So for factor 1, I have 1, 2, 3, 4, 5, 6 items that are loading together on that factor. I would figure out what those 6 items are about, and then I would name that factor.